Hello there! So either you were led here by my sorting algorithm videos, or YouTube just pushed this video to you. If you came from the latter, hi! I made 2 videos where I sort a set of bars using music. This video is an explanation of how I made them. To cater for the part of my audience who are not extremely nerdy, I will first introduce a little bit about sorting algorithms. More experienced viewers can skip to the part where I actually start talking about MIDI sort. So first of all, what is a sorting algorithm? It is just a systematic way of ordering a set of stuff. So for example, here are 5 numbers, and I want to order them in ascending order. One way you can do it is you pick the smallest number and you put it at the start. You find the next smallest, the next smallest, the next smallest, and the next smallest. And there you go, you have sorted them in an ascending order. What you just did was an algorithm called selection sort. There are plenty of ways to sort something. So let's do another example. Maybe this time, you just look at the first one. Then you look at the second one. 1 is smaller than 5, so you put it before 5. And then 4 is between 5 and 1. And then 3 between here. And finally 2 between here. This is insertion sort. There are fast algorithms like quicksort, and there are slow algorithms like bubble sort, which I will talk about here because it is related to how I did MIDI sorts. The bubble sort algorithm is simple. Start at the first element, compare it with the next one. If they are out of order, swap them. And then you move on to the next one and the next one until the end. At this point, the largest element will bubble up to the end, that's why it's called bubble sort. Do this n-1 more times, where n is the number of elements, and all of them will be sorted. One way to implement MIDI sort is similar to bubble sort. Instead of comparing the elements with its neighbor, I have a function that maps the nodes to a specific index, which is just a fancy word for position. And we compare the element represented by the last node with the element represented by the next node. If they are out of order, swap them. In the videos, this algorithm is actually not how I made them. It is actually way too slow. No, actually it is impossible to sort them. Let's take a look at this example. We start at this position, and then we compare it with this one. So 3 is smaller than 5, no swap. And then 5 to 2, we compare. 2 is smaller than 5, no swap. And then we move to 1, 2 and 1, there's a swap. And then we compare 2 to 4, no swap. And then we now loop the music. 4 to 3, no swap. 3 to 5, no swap. 5 to 1, no swap. 1 to 2, no swap. 2 to 4, no swap. You're stuck. So using MIDI bubble sort is actually impossible. Well, not impossible. It's not guaranteed that you will be able to sort the array. So the way I did the sorting in the video was actually fake. Instead of only swapping the last node and the next node when they are out of order, the nodes swap every time. When passing the MIDI file, I record what swap will happen, and I apply them in reverse to the array, pretending to shuffle them. That means given the same MIDI file, the shuffle array will always be the same. I've actually made this algorithm public as a website. You can upload your own MIDI files to play with it. Access the website at this location, which may not be my final decision on the domain, so keep an eye on the updated link in the description. Thank you very much for watching, have a good day, good luck, and goodbye!